Hey everybody, welcome to the September 2024 meeting for Tucson Amateur Astronomy's fundamentals group. For those who are joining, because I see some names I don't recognize tonight, which is always good. This meeting typically, depending on presenter availability, typically has two presentations. One, an astronomer of the month or another lighter topic. Um, we've recently started going back and doing some of our prior constellation of the month presentations because we're running out of things to present after 8 years. And then a second main topic presentation, which is generally on something general to astronomy, preferably that's applicable to what something that was helpful to you as an amateur astronomer, whether it be something about equipment, certain types of objects in the night sky, or or other general astronomy knowledge. So tonight, our first presentation up is by Pete Hermes, who will be doing the Astronomer of the Month on Al-Battani. And after that, I will be representing a 2018 presentation that was originally given by Doug Smith on star atlases, which are a useful thing to have in your toolkit when you don't want to ruin your night vision by staring at a computer. And that, Pete, you should have the ability to share. So whenever you're ready, go ahead and get started.
Okay. Okay, everyone should be able to see. Well, let's see. Maybe see the first page. Get rid of all the interferences. Okay. Anyhow, Connor, you can see the first page, okay? The cover.
I can, yes.
Okay, very good. So, hey, folks, thank you. It's always a pleasure and honor to present for the group. This month's presentation is on Al-Battani, who is an Arabic astronomer, probably, one of the most noticeable from the Islamic world, and probably the main bridge between Ptolemy and the rise of astronomy in Europe, especially with Copernicus a few centuries after this. But I'll go ahead and jump into it. I apologize, a little under the weather, a little congested. So let's see, I'm going to try to get one bar out of the way. There we go. And so my voice is a little bit under, and hopefully I won't have to cough too much. But anyhow, I will get right into it. Maybe. There we go. Anyhow, so the main points are going to cover a little bit about his life. Typically, with a lot of astronomers, prior to the Middle Ages, even prior to the Dark Ages, or actually this is around Dark Age time, there's very little known. We know them primarily by their work, so that would be the main focus. However, there are a few items about Al-Battani's life, given the fact that he was a little bit later. Still, we don't have, regular printing going on yet, so the distribution of information widely is not occurring yet, although we will cover one of his major works and find out that it was Latinized and was printed up and distributed throughout the known world, especially during the Renaissance, and actually proved to be a basis for a lot of work that was conducted during the Renaissance. And then, of course, I have a couple of references listed. By all means, if you have a earth-shattering question or a comment, just go ahead and pipe right in. My presentation isn't going to be that long, so we've got plenty of time and certainly can field any questions at the end. So diving into his life. Here you can see the entire name. Of course, Abu Allah Muhammad clearly identifies Al-Battani as being Islamic. You'll see the extended name, Al-Raqi Al-Harani. Al-Raqi was a location where he spent a large part of his life. Haran was where he was born. And Sabi speaks a little bit to some of the things that his family was connected with. For the most part, we believe Al-Battani was born sometime just before 858 Common Era. So this is what was generally referred to as AD previously, but Common Era in Haran. At the time, it was part of the Islamic Syria. It is now part of Turkey. You can see the little red dot. which is clearly just above Syria now, but at one point was part of Syria, but now Turkey, and lived for the most part in Raqqa, Syria, which is a little bit to the south of there, from about 877 to 918, where he performed most of his work, and we'll see where he conducted most of his observations during that time. He was more than likely the most notable astronomer of medieval Islamic world. For that, and to a large extent, with the exception of probably the Chinese, not knowing exactly because there wasn't much of an exchange, probably with respect to both Europe and the Islamic world, probably the most notable astronomer of that area. He also lived in Antioch and performed observations of solar and lunar eclipses around 901 CE. The son of Jabir al-Harani, who built astronomical instruments, thereby we somewhat understand why Al-Battani became an astronomer and an astronomer of note. He certainly had a familial basis in doing that sort of work. There's much belief, a lot of scholarly literature appears that shows his family was possibly affiliated with the Sabian sect of Haran. They're star worshippers. So you might think, okay, star worshippers, natural progression into becoming an astronomer. Of course, there was also a lot of work in astrology, but they certainly had an affinity for the stars. So this was something else that might have provided a basis for Al-Battani's work later on. Much towards the end of his life, pretty close to his death, there were some financial problems, which involved a move, and I'm not sure it's so much a move as travels, and maybe more than once, to Baghdad, even further to the southeast. And subsequently, this was an event that probably led to his death. He died in 929 near Samarra in Iraq, returning from Baghdad to protest taxes levied on fellow residents in Raqqa. That was something that he was involved with. I suspect he had some involvement with community affairs where he lived, given the fact that he might have been a member of the community or a citizen of some note, and that certainly contributed probably to his death, making some of these arduous travels. We can see pretty much, I think if you take a look at the time from when he was born, Al-Battani made it roughly a little over 70 years, which is pretty good for that time period. Like I say, his early education was most likely from his father, who built astronomical instruments. These are a couple examples, and principally, the astronomical instruments of the time were devices that were used to measure angles, specifically angles of elevation, with respect to being able to identify objects in the sky, how far they were above the horizon or from the zenith directly overhead. You can see some are, the one on the far left is relatively portable, small, whereas the one in the middle, in this case, it was a mural instrument, actually inscribed on a portion of a building. And then we have some, you can see the men standing next to it, a Turkish quadrant, in this case, quite large. And the whole point of this is the larger the instrument generally, the greater the accuracy. And trying to making these observations and making measurements and noting differences in measurements. More than likely, Al-Battani then, following work with his father with respect to astronomical instruments, probably received an advanced education in Raqqa, from who we don't know, from where we don't know. We know at the time there were other mathematicians, polymaths, astrologers, astronomers in the area that were already studying. And it's very likely he may have studied with them, but he was the biggest one to note. I think there was, I'm trying to remember the name, I think it was Thibault, or something like that. This was someone who was alive. He was more than likely alive when Al-Battani was born, whether or not he actually served as a teacher, but he was one of the other astronomers and mathematicians of note during that period in that area. So, like I say, the most that we know about Al-Battani is from his works, and probably the most seminal work of his. There were a number, but probably the largest and the one he was probably put the most amount of work in. And you can see the title here, Kitab Asabi, which is essentially the book of astronomical tables. And for any of you that know Arabic, you can certainly see that translation there too. But anyhow, It was one of the earliest astronomical tables, and for the most part is an extension of some of Ptolemy's work, especially with respect to his Almagest, which was a large compendium of observations, tables, and recordings, something I talked about, I think, quite a few months ago when I reported on Ptolemy. In all likelihood, with the exception of what might have been going on in China or other far extended portions of the world, when we talk about the Arabic world, Europe, these were the two seminal individuals that were bringing forth astronomy. The one thing that Al-Battani was able to do, he repeated a lot of Ptolemy's work, but with greater accuracy, it is believed, and greater specificity. A couple of the things he did, like I say, he improved upon Ptolemy's tables, adding original ideas in other tables, described horizontal and vertical sundials. One of the things I mentioned, there was a Latin version of his work, circa 1900. But there were prior versions before when movable type was developed, when printing became more common. And a lot of his works, like say initially from 900, and I think we talk about the late 1400s, 15s when we have printing available. Certainly some of his texts were transcribed into other languages and were released and were widely distributed. So he was real well known, especially in the European world, once that distribution of his, especially his primary work, the Book of Astronomical Tables, was distributed. It was comprised of 57 chapters. The beginning chapters, and as you read, form the basis for the rest of the book as far as describing the celestial sphere, degrees, signs of the zodiac, and some of the mathematical tools employed. One of the most significant differences between Al-Battani, and I shouldn't say between, but one of the most significant differences moving from Ptolemy to Al-Battani, now here again, this is what, 700-800 years. A lot of what Ptolemy did in describing his Earth-centric universe was based on the use of geometric figures. A lot of what Al-Battani tried to do was to use math more often than not, fractions and trigonometric functions to describe some of these things. And you'll see later on, I've just got to, I think, dive into a lot of the math work he did, but especially with respect to trigonometry, there was a fair amount that is attributed to Al-Battani as far as developing that particular branch of math and being applied for use in astronomy and astronomical observations. Moving on with the Kitab, and one thing too, I just wanted to go back a little bit about the language, and I'm trying to remember. Yeah, book. Essentially, Kitab would be, Zij would be astronomical tables. Zij is an old Arabic word that has to do with weaving, and it more or less describes the geometry of weaving, horizontally and vertically. So it only makes sense. It transcribes into becoming a list of tables where you have both vertical columns and horizontal rows. And of course, Kitab is
Did we just lose Pete?
I think so. It froze.
in the ensuing, chapters 5 through 26.
Hey, Pete, we lost you for the
Yes.
last 45 seconds.
Oh, I'm sorry. Okay, I tell you what, let me do something real quick. I think I know what the problem is. Let me get rid of something. Sorry for the interruption. And my laptop freaks out a little bit when I try to run too many things. I've only had one thing running, so hopefully this will improve that. Got me clear now?
So far.
Okay, very good. We'll go ahead and continue. Thank you. Anyhow, moving back, like I said, chapter 4 covered Battani's observations. Chapters 5 through 26 included various problems in astronomy presented based on the Almagest. So here again, a reiteration of a lot of Ptolemy's work, however, with a higher degree of accuracy and probably detail. Chapters 27 through 31 talk specifically about the motions of the sun, moon, and the 5 known planets, which would be the 5 inner planets: Mercury, Venus, Mars, Jupiter, and Saturn. The next few chapters, table legends and explanations for the readings. Here again, following chapters, problems in astrology, there was still very much a close relationship between astrology and astronomy at this time, not necessarily to explain each other, but more or less in some cases, especially, during this time period, developing astronomy was also tied to astrology, not so much that astrology could explain certain things, but we certainly know that there are aspects of astrology that come with the seasonal changes. And while they aren't necessarily predictive, they are associated with changes in the seasons. And then finally, the final chapter, sundial and other astronomical instrument construction, similar to some of the samples that I showed in the previous slide. Some other contributions and work. Al-Battani did establish his observatory at Raqqa. One of the significant aspects of this observatory was fairly close to the equator. So in looking at the ecliptic, the celestial equator, for the most part, being located at the equator would cut down a significant amount of atmospheric refraction, because at most times the ecliptic will be highest in the sky. Not all the time, but at least a greater chance that it would be. And of course, this helped improve the accuracy and some of the detail that Al-Battani accomplished with some of his observations. One of the things that he did develop with respect to solar observations, understanding the nature of annular solar eclipses. Battani was one of the first to understand that the distance between the sun and the earth did change during the year. And so he was able to explain the difference between, a total eclipse and an annular eclipse and how they could occur. He was able to accurately calculate the Earth's obliquity, angle between the equator and the ecliptic at, it's blocked here for me, just a second, at 23 degrees, 35 minutes. I believe the currently accepted standard today is 23 degrees, 44 minutes. And of course, the solar year at 365 days, 5 hours, 46 minutes. There's actually seconds appended to this. I think his calculation was within 2 minutes of the accepted norm, and understood the annual precession of the equinoxes. I think it was at 1 degree in 66 years, fairly accurately. I'm just going to touch on some of the trigonometry that Battani helped develop. Like I said, he certainly introduced trigonometry into his astronomical observations. He also expounded and expanded on some of the principles, introduced sines and tangents and calculations, updating and replacing previous Greek methods that have been employed. One of the things that he developed, and specifically, and I show it in 2 cases with respect to spherical triangles, one of the simplest of the formulas, the fact that cosine of a given angle is equal to the product of the cosine of 2 sides, the sine of one side, sine of another, and the cosine of the larger included angle. You see it planar, and then of course presented spherically. A couple of other principles that he developed is he understood that the tangent of an angle is the sine of its angle divided by the cosine, and that the secant was the inverse of cosine, and subsequently cosecant, the inverse of sine. So, I don't want to lay all these out, but these were some of these principles that he helped develop and made application in his observations and some of his explanations. Some other areas that his work was recognized and expounded upon. Al-Battani's data helped Copernicus some, 600 years later, derive the heliocentric model of our solar system. Some of his observations were used clear into the later Renaissance, even upwards towards the 19th and the very early parts of the 20th century. Battani's data was also used by Clavius, developing the Julian calendar, Tycho Brahe, Johannes Kepler, Galileo, and Edmund Halley. And that's why we see this progression, the use of some of his observations, some of his tables all the way up to the 20th century. He created a method for determining, and I'm going to butcher this, but Qibla, which is the direction towards Mecca, the second temple that the Islamic faith is concerned with facing when they pray. And in actuality, his accuracy wasn't the greatest in this case. It was only good for just a few hundred miles away from Mecca. For some reason, it wasn't all that accurate, but it was one of the first developments. And then he also established a basis for work in the rest. The accuracy of his tables and development of printing, like I say, after 1436, made distribution and circulation much easier. So, after 1436, his works were noted and were widely distributed through printing. Okay, and that's basically it in a nutshell. Those are my references. Are there any questions or comments?
Thank you for the flashbacks to high school and all the horrors that it brings with math.
Well, then you know who to is responsible for it. Thanks for that note. Yeah, that was back. God, what was that? 2022, almost 2 years or a year and a half ago on the Ptolemy presentation. But like I say, this was probably the next. And notwithstanding some of the folks that Doug talked about, especially with respect to, I think I did one on one of the subcontinent Indian astronomers, and I know Doug covered the Chinese, and not to negate or diminish their work, but with respect to this other half of the world, like I say, between Ptolemy and Copernicus, Battani was the man.
And also on that note, should add Edmund Halley to our list of astronomers we need to do at one point, because we apparently have not done him.
Oh, really?
No, I just looked.
Well, thank you. I appreciate your attention.
Anything else for Pete? No? Okie dokie. And with that, you're just going to jump right into it now. Move on to the next one. And when So I will admit I'm not as prepared for this presentation as I have been in the past. So I apologize. There's going to be a little bit more reading from the slides than I usually do. But Doug did a pretty good job on this presentation. So hopefully for those who are just getting in with this or looking for things to add to their kit, you'll hopefully learn something from this. And I am going to, can you guys see PowerPoint? I'm making sure I'm actually sharing the right screen.
Yeah.
Okay, cool. I also do apologize. I am going to keep the PowerPoint slide guide here on the left, just so that I'm not totally blindsided to myself. Because again, Doug did put this presentation together, and it's been a little while since I have had a chance to review it. So, getting right into it. And Doug, feel free to tell me what I'm doing if there's something that I maybe need critiquing on. So what this presentation is going to go to is going to talk a little bit more about like what are the purpose, what are star atlases and why are they useful for us, especially when with computers we have a lot of digital star atlases. Some background and history about the evolution of the star atlas. Why you should preferably have one in your equipment, especially for those who are going out observing. It is just a nice, quick, handy-dandy reference. We will make a brief segue topic on the epoch, which is specifically the period in which a star atlas was accurate. We'll talk about more about what that means when we get there. And then we'll talk about the different categories of star atlases that are available to us today. So star atlases, like almost every our fundamental telescopes and binoculars, come in as many shapes, sizes, and cover as many different things as our physical gear. They will have different trade-offs, usually in terms of what the objects that the star atlas will represent, or to the comprehensiveness, by which we mean sometimes they will show more, certain atlases will show more stars versus that are dimmer. Some will omit certain deep sky objects because they're not relevant to the star atlas. They might, and so forth. Many different reasons. And also try to give at least a good recommendation for, if you're not collecting star atlases for enjoyment, what might make sense for you to have as part of your field observing equipment. So there's star atlases themselves have a very long history. But despite how long we've actually looking at the sky, they're actually a somewhat more recent addition per se. But some pieces of the star atlas can be found much earlier than the first written records. With this particular cave drawing here from France, showing perhaps one of the earliest known star maps, which consist of some favorite winter constellations of Orion, Taurus, and the Pleiades.
Connor, could you do it in full screen mode?
I'm sorry, Dennis, I haven't had a lot of time to prep for this presentation, so I'm using the slide rule as a guide. So
okay.
I can kind of plan what I'm going to say ahead. I do apologize for the inconvenience. It is.
Thanks for doing it.
Make that a little bit bigger for those who might have vision problems. I hope that's a little bit better. So from that, we also get some early influence from the Chinese in the evolution of the star atlas. If you, although I personally cannot read most or any of this, there are some familiar symbols we might potentially see here. I don't have a laser pin on this slide. So if you look over here in the bottom corner of the left-hand panel, you'll see what actually looks like a little bit of the Big Dipper, or perhaps a Little Dipper. I'm not quite sure on what orientation this is. My guess would be on the Big Dipper itself, just because it's a much larger region of sky. Am I still audible? I might say, hello?
Yeah.
Okay. My headset just went weird. So, but the Chinese and their own contributions have for almost as long their own separate mythology that's different from what we know, which is primarily a combination of both Syrian mythology and Greek mythology for our constellations. Sorry. So the first, skipping over all of that now, we wind up with Ptolemy, who we've heard his name dropped a couple other times so far tonight, who was essentially responsible for forming the first star atlas, using that term somewhat loosely here. He was essentially the first person to go out and catalog all the stars he could, well, many of the stars he could see, certainly not all. There's some where we sit there and go, how does this not in your list? But he would spend much of his time trying to catalog, not necessarily name, stars according to their brightness, which is where we get part of the apparent magnitude system that we still use today to denote star brightness, at least for the context of amateur astronomers. Professionals have their own system that of absolute magnitude, and it is what it is. He's through a lot of effort. I'm not quite sure if he had any assistants helping him with this. I can't remember back to Pete's presentation from 2 years ago. Had assembled a catalog of about 1,000 stars, and spending a lot of time to measure their rough positions in the night sky, and record them over time. Because of a combination of things such as the stars' relative motion and the precession of the Earth itself, some of these positions are no longer accurate, which we'll talk about more in epochs. Others are still quite correct. Yes. And all of his observations were made at around 54 AD. So after his work and, getting kind of out of the Dark Ages and more into the Middle Ages, back before we had printing presses, the Star Atlas was very much a work of art. Many of the diagrams, since you couldn't really print a Star Atlas even with the Gutenberg press preliminary, just because it's too I'm not quite sure how you would. You would have to otherwise etch metal plates very precisely in order to print them, which was slightly different. So these were very laborious to produce, which kind of gave the creators an incentive to go a little crazy and add some art to their work in order to, maybe show off their abilities, or to just increase the value of the work to say, to make it more digestible or appealing to the rich nobles who might have been able to afford a Star Atlas, especially if you are particularly a rich merchant who is the captain of a ship making voyages across the Mediterranean or the west coast of Africa and Europe for trade purposes. Before we get into the great age of exploration with Columbus and Magellan. So these were very much both served an artistic purpose and a practical purpose, especially with the use of the prevalence of astrology during this period. So after we get to Ptolemy, his Star Atlas is the work that Ptolemy asserted is the basis for most Star Atlases for many hundreds of years. We have to go quite far into the 1600s to find works that start building on Ptolemy's work rather than just using it verbatim. And we wind up with I want to say Johann Bayer, or if I'm getting his first name correctly because it's not on the slide, with his seminal work, the Uranometria, which I think we have, Doug, correct me if I'm wrong, we have a hard copy of this in the club library. Do we not?
Not this one.
No, I mean, not this,
There's a newer
but a
copy.
reproduction of the Uranometria.
No, we don't.
Oh, okay. I know that there's some in this presentation that we did, and I'm probably jumping ahead of that.
There are new atlases out that are named Uranometria, but it's not this one.
Okay. That was my confusion then. So what Bayer did was catalog. His book consists of 51 star charts encompassing, I think, both of the hemispheres, primarily the northern hemisphere, which we had a lot more time and observations for. But he was also notable. This was also the first Star Atlas that actually included observations from the southern hemisphere and some of the first southern constellations. He built this work again off of Ptolemy, but in addition, he added observations from Tycho Brahe, who was active during the same period from the northern hemisphere, for both the northern, who was active in this period for both observations and some observations in the northern hemisphere and for some observations in the southern hemisphere. The charts were quite accurate at the time, accurate enough that I think this were in some ways used for navigation, but I don't have, that's just me coming off the top of my head. I don't have any references to cite that to. But he also would assign, gave these atlases brightnesses and established what we know today and we've seen occasionally throughout some of our meetings is the Bayer designation, which is most notable in giving a Greek letter to many of the brighter stars in the constellation, like say Alpha Centauri. Alpha is the Bayer designation for the brightest star in the constellation Centauri. So very influential work. Still, pieces of it are still used even today. So after Brahe, this kind of went into a static, I want to say limbo, where there just wasn't a lot of effort to assemble more comprehensive star atlases, especially with, which is odd considering how many new things were discovered in the 16 and 1700s alone, just from major expeditions into the southern hemisphere by astronomers of the Age of Discovery. So it's kind of this weird gap between that and the next couple hundred years until I think the 1800s, if I'm catching this up correctly, where the Silas really didn't progress much between this half art, half science book. And as you know, as I touched on, many of these star atlases were hand drawn for a good while, just because of the difficulty of trying to get some of this onto a printing press. So very much work to come.
Hey, Connor?
Yes, Doug?
No, okay. By the way, these 3 slides that you just showed, including this one here and the 2 previous slides, we have these.
Okay. Thank you, Doug. So getting into the 1800s, now we skipped, roughly 200 years of, astronomy history, at least for the context of the star atlas, because of the lack of progress in this area. But we start seeing an uptick in books written for amateur astronomers. They're average citizens. Education has improved enough where people who aren't necessarily scientists or very well educated or professionally educated, began to take a more personal interest into astronomy and what it can tell them about the night sky. And this gave a very big drive for having books and reference material for these amateurs. Key among them was the Star Atlas. And this is, for those who might be having trouble seeing this, the book shown on this page is The Constellations and How to Find Them by William Peck. I don't think the other two, I think this might, I'm not quite sure where this particular one came out of. Doug, do you know?
These are just pages that I got a hold of from old star atlases. This one's from 1876, and the one before that's even a little older, I think. The slide before.
Yeah, I was just wondering what atlas this page came out of.
I don't know where they came from.
Okay.
I don't know where they came from.
No worries. So with this new need for a lot of printed material to help amateurs navigate the night sky, we start also seeing some of the first introductions of the constellation boundaries, which will later be solidified in the 1920s by the International Astronomical Union. But many of these early star atlases used, the authors often use their own conceptions of what these boundaries should be when dividing up the constellations in the night sky, or in some cases, cataloging which objects would belong in which constellations. For those that may have seen a star atlas today, you'll often see that sometimes an object will be and that atlas will be in the boundaries of one constellation, but then sometimes if you look it up in a digital atlas, it'll be in a completely different constellation. Same thing is still going on here, where sometimes objects get put in different constellations depending on who made the atlas. I don't know why that still happens when we have official boundaries for the constellations, but it does. Then we start getting into the 20th century, where we've had much better ability to print books, especially with figures and drawings. And we get into some atlas names that I think are still in use today. Norton's is still an atlas that's published today. Doug, did not know?
Absolutely.
That's a yes.
Absolutely.
How about you shook your head like it was a no? That's what I was like. So Norton's atlas, certainly. Oh, there it is, right on the slide today. Should have learned to read. Um, uh, mm, sorry, need to catch up my thoughts. We get some of these atlases that were still in production today. And some of them are, very prominent within the community, like Northern's Atlas here. But at the end of the day, at least until the Gaia satellite, assembling a star atlas is still a very laborious process. And in fact, it has a name for it with a stellar cartographer, which exactly what it sounds like, a stellar map maker. Yeah, double pun there. A couple of really prominent names in this include Will Kirian, Antonin Beckvar, and Hans Wernberg. I'm glad I got all of those right on the first try. That was hard. They each, in their own ways, contributed impressive atlases in different ways. Trinian created, was responsible for making an updated version of the Uranometria also producing the Cambridge Star Atlas and the Bright Star Atlas, among others, which were, going by this slide, very prominent atlases for the periods in which they were produced. Antonin Beckvar, excuse me 1 second to read this. Eventually produced, his key contribution was what has since become the Sky Atlas 2000.0, and several other atlases, which I'm just going to skip over because that's just a lot of words. But there are, if you know,
we have Borealis, Eclipticalis, and Australis in the library. And if you ever want to look at a really interesting atlas, those are good ones to look at.
Thank you, Doug. And Hans Verburg was created, at least completed several photographic atlases, which were, I'm not quite sure what he used to take his pictures, since they were photographic atlases. But
used a Celestron 11-inch camera. He used the Schmidt camera.
That's a lot of focal length to produce an atlas. That must have taken him a while.
Those Celestron had a set of Schmidt cameras. They had a 5.5-inch and an 8-inch. Back in the 60s, that you loaded the film into the camera at the prime focus of the Schmidt Cassegrain, 1 frame at a time.
Oh, so it was like a hyperstar of the day.
Almost like a hyperstar. Very similar, except they used film. And he took those cameras and went around the world to different places in the northern hemisphere. And he went down to South Africa to do the southern hemisphere. And he developed those 2 photographic atlases, the Fokker and the Stellarium. And we have the Stellarium in the library.
The Stellarium here, I believe, is different from, well, what some people may use as a web app of Stellarium. I believe that they are two, just they are very distinct and not from the same person. just
Yeah,
to
it's not the same.
avoid ambiguity there.
Yeah.
So the question now is, we have all these atlases, but why? Why do we still need these today? Why are they important? And predominantly, the main use case is for those that still engage in visual observing. It helps act as a way to preserve your night vision. Staring at a white light computer will reset your night vision and make it your eyes less sensitive for staring at faint fuzzy objects. But another thing that makes them helpful is that for those who aren't necessarily well skilled with computers or don't want to learn a new app, it's trivially easy to open up a book and figure out, hey, this constellation is on this page. Click and find out the things you want to see. Well, some of the things you want to see. So in that sense, they can sometimes be much more user-friendly than a digital atlas. And, you know, everyone knows how to operate a book. And another benefit that Doug helpfully points out is they are a lot easier to, a lot harder to, they're a lot less expensive to get damaged. You know, if you spill coffee or something on your laptop, or, you have an old laptop that you're replacing every, 6 or 7 years, having to recover all of that versus a book, you just pull it off the shelf, it works and goes. So even though I do personally do a lot of photography, I still keep a star atlas in my gear for a variety of reasons. Sometimes just to remind myself where stars are in the night sky when I'm looking for alignment stars. So they still very much have their uses and are still a welcome addition. So with that, now we need to make a quick transition and talk about the epoch. And this is essentially a snapshot in time that represents when a star atlas, when the positions recorded in a star atlas are valid. As mentioned earlier, stars will over time drift slightly out of position. Sometimes, fractions of, arc seconds at a time, sometimes up to arc minutes every, your decade. It very much depends on the star. So these, stars are in motion. So you have to, and books represent a static snapshot. So they do need to be updated occasionally. And by occasionally, this is every 20 to 30 years. So if you go and look at an atlas that was printed in 1930s, 1940s, and tried to find Arcturus, it's going to be in a very different position today because Arcturus is a very fast-moving star. But I know, of course, over the course of your lifetime, you won't really see much of this. These differences are very small. But for those using go-to telescopes, they actually have to account for this in their circuitry. Otherwise, you end up pointing not at the thing you're pointing in the wrong direction. Well, you end up having difficulties finding the things you're wanting to look at. So they do have to account for this drift within your telescope's hand controllers. So having the wrong epoch is a very easy way to not find the things you're wanting to look for. And as helpfully noted here, the epoch we're currently in is what's known as the 2000 epoch, which you'll often see reference as well when you look at Wikipedia pages. You'll see underneath some stars or constellations or deep sky objects, if you look at the Wikipedia pages, you will see a J2000 number denoting their particular coordinates. So there's also a J now epoch, which I think has a different reference point, and we won't get into because it's really more for professional astronomers, but also on really high-end equipment that we can get as amateurs. I think certain mounts will internally use the J now epoch, but we'll ignore that because it's complicated, and I don't want to get into it. So
one thing I would, can you go back?
Sure.
One note I would make um, is that bottom paragraph that talks about the epoch interval. Most of the star atlas companies have published these star atlases now. They do it every 50 years. Like there was a 1950 epoch. Most of those star atlases were published in 1950, and now they're all published with the 2000 epoch. So the next epoch that'll come out will be the 2050 epoch. Now, next year's 2025, so after January 1st of next year, we're actually closer to the 2050 epoch than the 2000 epoch. You might actually start seeing star atlases for sale with a 2050 epoch on them. So it's something to look for, because if you're young, like Connor, it may make a difference. And it doesn't make much difference to me. I'm not going to be around another 50 years, but for someone who's young, they might want the better atlas with the more accurate positions.
Thanks,
Hey,
Doug.
Connor,
Yes, Pete.
Archie's got a good question in the chat.
Yeah, I saw it.
It's pretty good.
Oh, thank you. So Archie is asking, why do some stars move faster than others? This is a combination of factors. One of them is that particular star's proximity to Earth. Some stars that are closer will appear to move quicker just by the virtue of being closer. For example, a car in front of you going at 60 miles an hour will go across your field of vision much faster than a car 5 miles away going at 60 miles an hour. The same principle. Other ways is that not all stars are moving at a uniform speed with each other. Some stars are going faster relative to other stars, even at the same distance. This will again
The rotation
change
of the galaxy.
that. Thank you, Doug.
Yeah, the stars are
there-
moving at different speeds based on how far away they are from the center of the galaxy.
Yeah. There are also some stars that are not going in the same direction as the rest of the stars in the Milky Way. Arcturus is one example of those, where its orbit is actually perpendicular to the plane of the galaxy. So lots of reasons. Very good question, though. So moving on, we get to talk about the different types of star atlases that you might want to look at your gear, depending on what your observing needs are. At the time when Doug gave this presentation, he had a physical copy of each of these types of atlases that he was passing around the room. Unfortunately, this is an online presentation, so we don't have those physical artifacts to pass around here. So some imagination is required. But they, depending on what you want to look at, the star atlases will cover different things, from naked eye, binocular targets, high magnification telescopes. Some of them are just pure reference, and then others are photographic atlases, which Doug, by photographic here, do you recall if you meant an atlas that shows things that you can, intended for astrophotographers to find things of interest, or an atlas that's just pictures of the sky to serve as a photographic atlas? Does that make sense?
The latter.
Latter, okay.
Barenberg's atlases for photographic atlases.
Right. I just wanted to make sure I understood what you meant by this. So first off is naked eye atlases. These, by their name, will only show stars and occasionally the select handful of deep sky objects that are visible to the unaided eye. There are a handful of deep sky objects that do fit this category, so they will depending on the completeness of the atlas maker, they may or may not be there. But for human vision, the limit, the general consensus for the limit of human vision, mouthful, is a parent magnitude 6.5. If you're so an object that is magnitude 7 is generally considered not observable without the aid of binoculars or a more powerful binoculars or a telescope, excuse me. They are generally useful to novices who are just trying to learn the night sky, particularly the constellations themselves, without having to deal with all the background clutter you might get on a binocular binocular target atlas or a telescope target atlas, which will cloud, which may confuse you, or with dimmer stars that you can't physically see. As Doug notes, some of them may also contain lunar maps and some information on the planets as just a general reference. One good example of this is the handy planisphere. These, if you've ever been inside of a gift shop at a national park, you've probably seen one of these, or into an astronomy shop here in Tucson, like say Starzona. They appear everywhere. Planispheres are geared to a specific latitude and longitude, which is usually printed on the planisphere itself. You will
Not
occasionally. What, Doug?
Not longitude, just latitude.
Latitude, my brain works. You will sometimes find a planisphere that does not mention this. I actually have one on me. I got it out of the gift shop at the Grand Canyon in 2016, and it does not mention what latitudes it's for, and it really confuses me when I try to find things with it. So do look to see if you do want a planisphere, which is still a nice thing to have in your kit, that you're getting one that's valid for your latitudes, because I'm pretty sure mine isn't. I think it's valid for like latitude 50. Which is really, really hard to use when we're down here in Tucson at latitude 32. It confuses me every time I bring it out. But they're just a single disk that represents the entirety of the night sky for a specific night and season, just showing what constellations are up and where they might be positioned within your reference, within your field of view.
And bigger is better.
It depends.
It is easier
If
it is
you,
to read.
bigger is better in terms of readability. But again, if you're wanting something that's portable for taking it out in the field, carrying around a 3-sheet of paper within potentially high winds, not necessarily the better choice. So there's a balance.
Yeah.
In all things. Moving on, we go into, I believe this is your first take. No, this is a visual going by the slide. So this is still in the range of visual star atlases. This is a sample from Northern Star Atlas, which we briefly mentioned earlier. It, like other atlases, it just shows here's visual stars in visual magnitude that you can see and right ascension and declination. But it does do a sort of Mercator projection so that they're more accurate in terms of position, just because of how big the slices in the sky be. So that's why this atlas is curved. Sometimes you will see atlases that aren't curved simply because they represent a smaller portion of the sky, and so the geometric distortion of that smaller slice is less pronounced, so they can get away with having square edges, like in Sky and Telescope's Pocket Atlas, which is what I keep in my gear, which doesn't have these distortions. This is a sample of another atlas, which I think was one that Doug passed around the room at the time, which is the Observer's Sky Atlas. Doug, I don't know if there's anything you wanted to mention particular about this atlas or why you included it here, if you even remember.
The author.
Oh, Eric Kokoska. Okay, thank you.
Yeah, he's one of our club people.
Yeah, so this was, as Doug points out, which I didn't see, this was made by a member of the club for professional print. So,
and we have this in the library.
And then this is a example of a page from the Will Tyrian Atlas, which we mentioned this author earlier. that does have, in addition to individual pictures, it does have coordinates and object names, which is helpful with, unlike the Sky and Telescope Pocket Atlas, which is the one I keep in my gear. You have to know the objects to more sort of make sense of some of the numbers on the page. And if you don't know what they are, it's kind of useless to you. So if you are a beginner and don't know much about the night sky, this would probably be one of the better atlases if you just wanted to flip through and get kind of a sense of like, hey, what is this thing? Where is it? And what type of object is it is? I think that this would be a tad more um, first time user friendly than the Sky and Telescope Pocket Atlas, which is designed to be very compact.
Yeah, the Norton's has the similar tables. After each chart, there's a page that has the tables of all the objects in that chart, all the NGC objects and so forth, like this, but it's on a different page from the chart.
And then this is a very field guide of planets and stars. Moving on from that. So after that, we get into binocular and finer telescope star atlases. For those who might be using a TELRAD or a red dot site to help find things in the night sky, if you're very old school or want to do setting circles, or have a DOB and you're using a TELRAD on a DOB to help find things where you're not using a go-to system. This would be a helpful type of atlas to keep with you, and so that you can cross-check that you're pointing your DOB in the right direction. So one example clearly is the Sky and Telescope Pocket Atlas, which is, as we said, this is the one I keep. It is very compact. It's about, I want to say 4 inches by 6 inches. Just to give it a scale. They also have a much larger version. It is quite useful. I primarily use it to help remind me where a particular guide star is, like Enif and Pegasus. And as I mentioned, it is still set on the, at least the versions I have, or many of us have, are still on the so-called J2000 epoch.
Yeah, I haven't seen a 2050 epoch yet, but they're coming out soon.
This is another atlas that was also contributed by Wheelitarian but primarily crafted by Skalnate Pleso. I butchered that name horribly. I do apologize.
Skalnate Pleso.
Thank
and
you,
that's
Doug.
a place, actually. That's the name of an observatory. And Beckfar named it after the observatory that he worked in.
Okay, thank you. This is
Beckfar, by the way, is responsible for this color scheme where nebulas are green and galaxies are orange, and he's responsible for the color scheme used in this atlas and in the Sky and Telescope Pocket Atlas.
Thank you, Doug. So this is a useful atlas for both deep sky objects, which you might see at binocular range, but also has information about double stars and some other high-level information that you might find useful. This is just another sample page out of a Tyrian atlas, which looks similar to the Sky and Telescope atlas. It might just be a scaled up version where they're of each other. And the Interstellarium Atlas, that, and then
okay, go back to that one for a second. Don't buy this one. What's wrong with the colors?
they're red, so if you want to look at them with a red light, you can't really see much.
Those things disappear under a red light at night. Bad choice of colors for this one.
Moving on from binocular atlases, we have telescope atlases, which are basically the same thing as binocular atlases. They just show dimmer stars up to 11th magnitude, sometimes even dimmer, depending on
Usually larger scales too. They're usually much larger scales.
By that he means that the field of views they see are smaller per page.
The 1 degree by 1 degree scale on the chart is much bigger than what you see on the other atlases. You're
Oh, okay.
less
Yeah.
less stuff on a page, so you need more pages.
So this borrowing the name from the Uranometria. This is was also made by Wilterian, designed spans a couple of volumes just because it shows, as we mentioned, each of the pages shows a much smaller area of sky, so that it could basically have a high magnification, which is useful for making it easier to find these faint fuzzy objects if they're, say, magnitude 10. But also makes it sometimes, I want to say, easier for certain types of double stars, which have decent separation to be more easily seen. Like, for example, here, these pairs of stars, which here near NGC 6416 as an example. I'm not quite sure if those are double stars. I'm just making it. And this is just another, so skipping that slide. There are some atlases which are not necessarily intended to be used in the field. These would be more interesting if you were trying to find very specific things.
You skipped the Millennium Star Atlas?
I did.
You did. You shouldn't. That's a good one. I've got it.
I don't want to. I want to get through the rest of these slides.
Sure. Okay.
just for the sake of time.
Yeah. Okay.
Reference atlases are not. They're like more what you would see if you're trying to cross-reference things. What you might have seen before digital atlases, if you were looking at a glass plate and trying to cross-reference or find something within a field of view, was what I would think that we were originally conceived for, was to serve academic reference rather than as, what we might take out in or use onto a regular observing session, just to correlate, if you're research materials. So they are, in this particular example, doesn't label anything, at least on the individual page, but there is just a lot more information per page in this example.
Yeah, on these atlases, back far, there is not a single deep sky object in these atlases. They are literally just star atlases. Every star is down to about, I seem to remember, 13th magnitude is shown on these atlases. The scale of the charts is enormous. I mean, look at the scale there. You're talking about just a few square degrees covering a whole page. And these are big pages. These pages are like 30 inches by 20 inches. They fold up into the binder. But one of the things that's most noticed about this is every star has its spectral classification noted by the color of the dot on the atlas. So every star that's been cataloged and has its spectral classification known is marked on these charts. They're rather impressive works. We have them in the library.
And then finishing it up here with photographic atlases, which are simply, a star atlas laid over a photograph, like you might go out if you're imaging something. I personally do not have a star atlas like this, but there's they're pretty to look at if you're like looking at images in the night sky and try to orienting yourself uh to where an object might be in a little bit more artistic manner. This so one example of these comes from Hans Wernberg, who we mentioned earlier. This was using the 8-inch Celestron camera produce this photographic plate set. So this is this particular page is centered around Polaris, since it is 0 hours of right ascension plus 90. So this would be the area immediately around Polaris, I think, if that's the center of the page.
Yeah, that's Polaris there.
So recapping all this, so if you were to go out and buy an atlas, my suggestion would be like any telescope, get one that you think you're likely to use or take out with you in the field, or at least that is the most helpful. If you're at your scope and you're trying to say, hey, what should I go look at? What am I pointing at in the night sky? Why can't I find this object? Having an atlas that you can quickly get to when you're behind your telescope is useful. So that would say, at least for people using Dobbs or binoculars, setting a naked eye atlas or a binocular level atlas. I personally don't think a lot of people need a telescope atlas nowadays. A lot of people have more transitioned over into digital for that, especially for some people who might be looking at certain things. So depending, the telescoped atlas decision, in my opinion, is more of a preference rather than a need. Especially because the telescope atlases sometimes might be a little bit big, especially if you're working at 8 inches or 10 inches of aperture. So my personal recommendation would be something like the Sky and Telescope Pocket Atlas is a good starting point. And then once you get used to it, going up from there or going digital. But as we've said, there's trade-offs to digital atlases, which depends on the person. And that's it. That's it for this presentation slide deck. That was a lot. Any questions or comments on any of that in there? There was quite a bit.
Bravo, well done, Connor.
Thank you. So don't have any questions yet. So with thinking, I'm going to go ahead and call this a meeting and end it here for the night. So and with that, with the make sure I want to make one quick request when I make sure I've actually stopped the recording.